A very warm welcome to all the budding scientists. Today, we are starting the unit of electricity. Electricity क्या है? इलेक्ट्रिसिटी एक फॉर्म है एनर्जी की जिससे हम अपने घर के अप्लायंसेस चलाते हैं और भी बहुत जगह इस्तेमाल होती है. इलेक्ट्रिसिटी इज़ अ फॉर्म ऑफ एनर्जी which is caused by the movement of charged particles through a conductor, and it is used to power up the appliances, devices, and but natural, our mobile phones. How is electricity generated? Because it is a form of energy, and from the law of conservation of energy, you know that one form of energy can be converted to another. So in this, the movement of the charged particles, that is the kinetic energy of charged particles, is converted into electrical energy. And the flow of charged particles and the readily available charged particles that flow are electrons. The flow of electrons through a conductor cause electricity, and it serves many purposes: powering equipment and appliances, lightning, enabling information transmission, communication, and many others. Now, electricity is actually flow of charge, but first you have to understand what is charged. Have you rubbed two balloons together, or rubbed a balloon with a silk cloth, and if you paste it on the wall, it sticks to the wall all by itself. वो अपने आप बॉल पे चिपक जाता है बिना फेविकोल लगाए. क्यों? क्योंकि उसके अंदर रबिंग से एक चार्ज पैदा हो गया है. A charge is developed into that balloon due to rubbing. Why? क्यों? जब भी हम किसी दो ऑब्जेक्ट को रब करते हैं, like we rub a glass rod with silk, or we rub a plastic piece with wool, it gets charged. Charge develop होता है. क्यों होता है? Because when we rub together two objects, like we are rubbing plastic with wool, in that process, some electrons from the plastic get transferred to the wool. How? They jump. Because there are numerous of electrons, and some of the electrons which are loosely held, they tend to jump from one material to another. So one material is deficient in electrons, the other gets excess electrons. तो उस ऑब्जेक्ट में जिसमें इलेक्ट्रॉन्स ज़्यादा हो गए हैं वहाँ पे नेगेटिव चार्ज डेवलप होगा, और जहाँ पे इलेक्ट्रॉन्स कम हो गए हैं वहाँ पॉजिटिव चार्ज डेवलप होगा. वाई? Because electrons carry negative charge. Fine. So, electric charge is a fundamental property of matter that causes it to experience a force when placed in an electric or magnetic field. It is a property of subatomic particles such as electrons and protons. Protons also are subatomic particles which carry positive charge, but they are existing in the nucleus and they cannot move freely as electrons. Now, we know that electrons, the flow of electrons cause current, and the movement of electrons or the jump of electrons, it causes a body to get charged. चार्ज पैदा हो जाता है. अब चार्ज की बात हम कर रहे हैं तो हमें यह पता होना चाहिए कि चार्ज कितना है. There it has to be a measurable quantity. तो चार्ज को मेजर करते हैं हम एक क्वांटिटी से जिसे हम बोलते हैं कूलम, और उसका सिंबल है कैपिटल C. द कूलम इज द यूनिट ऑफ इलेक्ट्रिक चार्ज. प्रोटॉन्स कैरी पॉजिटिव चार्ज, इलेक्ट्रॉन्स कैरी नेगेटिव चार्ज. दिस यू ऑल नो वेरी वेल. हाउ मेनी इलेक्ट्रॉन्स get together to form 1 coulomb? 1 coulomb is the amount of electric charge that pushes with a force of 9 into 10 to power 9 newtons when another equal charge is kept at a 1 meter distance from it. This is the quantitative definition of 1 coulomb. One electron carries a charge of 1.6 into 10 to power minus 19 coulomb. So there has to be a fixed number of electrons that makes 1 coulomb, that is 6.25 into 10 to power 18. This much electrons get together to constitute 1 coulomb of charge. The total charge of 6.25 into 10 to power 18 electrons is equivalent to 1 coulomb of charge, and the coulomb is the SI unit of charge. Electric charge is a property of matter responsible for electric and magnetic properties. Coulomb is the practical SI unit of charge, and charge is a scalar quantity because it has only magnitude and no direction. Properties of charged particles or charged bodies. If two similarly charged objects are kept close together, they tend to repel each other, and if two oppositely charged particles are kept together, they tend to attract each other. So we can say that like charges repel and unlike charges attract. Charge is conserved and additional. If we transfer charge to an already charged body, then the additional charge gets added to the original charge. That means the total charge will be, suppose a body had a charge Q1 and we supplied another charge Q2 on it, then the total charge will be Q1 and Q2. That is, total charge is conserved and charge is an additive property. Charge is quantized. What do you mean by quantized? Suppose you are going in a building, you're climbing the stairs. How many stairs did you climb? It's always a positive integer. You will never say that I climbed 19 and a half steps or 25 1/2 steps. Is it possible? No. Steps are always counted in integers. Similarly, charge is also quantized because the fundamental unit of charge is the charge that is existing on one electron, that is 1.6 into 10 to the power minus 19 coulomb. That is the smallest possible quantity of charge that can exist. And if we accumulate charge, it gets accumulated in the multiples of that fundamental unit. That's why we say that charge is quantized, meaning it exists in discrete amounts. Electric current. We know that current is what? Current is movement of charge through a conductor. If electrons are flowing through a conductor, we will say current is flowing. If alpha particles are flowing, we will again say it will constitute a current. That means if charge is flowing, it is called current. Now, alpha particles are, or we say positive particles, and negative particles are electrons. If electrons are flowing in this direction, then we will say the current is flowing in this direction because electrons are negatively charged and the direction of current is always opposite to the flow of negative charge. But if alpha particles or positive particles are flowing in a particular direction, then that particular direction will be considered as the direction of current because it is the direction of positive charge. We always consider current as movement of positive charges. So the direction of electrons is always opposite to the direction of current, or we could conversely also say that direction of current is opposite to the direction of flow of electrons. हमेशा करंट इलेक्ट्रॉन से उल्टी डायरेक्शन में फ्लो करेगा. जिस डायरेक्शन में इलेक्ट्रॉन्स फ्लो कर रहे हैं, करंट की डायरेक्शन उससे रिवर्स या ऑपोजिट होगी. Thus, SI unit of current is ampere. कैपिटल A से इसे रिप्रेजेंट करते हैं. और 1 एम्पियर. What is 1 ampere? 1 ampere is when 1 coulomb of charge flows through a conductor in 1 second, then that current is known as 1 ampere. That means 1 ampere per second is 1 coulomb. So we can say that current is actually the rate of flow of charge through a conductor. If 1 coulomb of charge will flow through a wire then a current of 1 ampere runs through it. The magnitude of I, that is electric current flowing through a conductor, is measured by total charge flowing through that conductor divided by total amount of time it took to flow through the conductor. That means total charge flowing and the time required for the flow of that charge, that will constitute the current. That means the ratio of charge to time is called current. One ampere equals 1 coulomb or 1 second. This thing you should always keep in mind, because questions are generally asked in your board exams, like define 1 coulomb, define 1 volt, define 1 watt, like this. So for that, you keep this in mind, that 1 ampere equals 1 coulomb upon 1 second. This you can also write in words, so you will remember that. Now comes circuits. What is a circuit? करंट को फ्लो होने के लिए एक पाथ चाहिए जिसमें वो फ्लो होगा, उसके अंदर बाकी अप्लायंस भी लगे होंगे. तो उस क्लोज्ड पाथ को जिससे करंट फ्लो करता है उसको इलेक्ट्रिक सर्किट कहते हैं. सर्किट इज अ क्लोज्ड लूप दैट परमिट्स द फ्लो ऑफ इलेक्ट्रिक करंट. Conversely, or in other words, an electric circuit is a closed loop that creates an uninterrupted path of electric current to flow, enabling electricity to travel from power source to a device or location where it is required to do some work. It typically includes resistors, capacitors, power sources. Power source अगर नहीं होगा तो करंट ही फ्लो नहीं करेगा. That means power source is an integral and a necessary part of a circuit. This you can see is a typical or representative form of a circuit. Here the power source is a cell. This is a switch and this is a device. Here we have used a bulb. You can use anything like a buzzer, like a ringer, or like a spinner, whatever. This power source, this battery, this cell, it consists of chemical energy, and it has a mechanism, it has a propensity to convert that chemical energy into mechanical energy of charged particles. And that charged particles, when flow through this conductor, will create current. So in short, simply we say that this is the power source, the source of current. It has two terminals, one positive, one negative. And conventionally, we take the direction of current from the positive terminal through the circuit back to the negative terminal. That is, the current now completes one complete loop. This is a switch which permits the flow of current. Whenever we don't require the current, we simply switch it off. Switch off means now the circuit is broken. No current can flow through this now. So it is called, when we turn this switch off, the circuit is broken. And we say that the switch is open. Switch is open means now the current is interrupted and it is not going to flow. But when we close the switch, then the loop is closed. Switch closed means we have turned on the device. When you want to turn on a device, you simply close the switch. And when you turn off the device, you open the switch. Open switch means no current is flowing, and closed switch means circuit is complete, the loop is complete, and the current will flow. This is the diagrammatic representation of a circuit. Here, this shows a battery. If one big line and one small line is there, it is represented as a cell, but here it is a combination of cells. So a combination of cell is known as a battery. This is a switch, parenthesis with no dot in it. Now this says that it is open, means the switch is open, no current will flow. And here is your device which you want to work upon. This, our dot is put here, rest all is Same. This dot means the switch is now closed and the current is flowing and your device is working. When the components of a circuit are connected, that means the circuit is closed, the electrons flow from the battery to the device and return to the battery. This is how current operates. Electrons will leave the battery from the negative side and enter the battery to the positive side, but the current will flow from positive side to negative side as taken convention. These are some symbols that we use in our circuit diagrams. This is an electric cell. A combination of two or more cells is known as a battery. This open switch. Next is the closed. Two wires with a dot at the connection. That means the wires are joined together. That means the current will flow at the joint. But if a bridge kind of thing is there, then the wires are crossing over each other and no contact is between the wires. This is a symbol of electric bulb. This zigzag line is a simple resistance. A zigzag line with an arrow on that is a variable resistance or simply a rheostat. A circle with plus and minus and A written on in it, it's an ammeter. Ammeter is a device which used to measure current, and if V is written there, then it is supposed to be a voltmeter. Voltmeter is a device which used to measure potential difference or simply voltage. The electrical circuits are depicted using these symbols. Electric potential. What do you mean by potential? Potential means how much work capacity you have to do work. More potential, more work, less potential, less work. Potential, this term is also used in general terms, like this particular candidate has a great potential to be some such and such thing. That means capacity. So potential means capacity. How much potential means how much energy that can give to the system. Electric potential is the amount of electric potential energy per unit charge at a specific point in an electric field. What is electric field? Suppose we keep a charged object. So about that charged object, there has to be a certain space in which its effect can be felt. किसी चार्ज ऑब्जेक्ट के अराउंड कुछ ऐसा स्पेस हो जहां पे उसका अट्रैक्टिव या रिपल्सिव फोर्स एक्सपीरियंस किया जा सके, उसको कहते हैं इलेक्ट्रिक फील्ड. उस इलेक्ट्रिक फील्ड में अगर हम सिमिलरली चार्ज ऑब्जेक्ट लेकर आएंगे तो वो उसे रिपेल करेगा और हमें उसको ऑब्जेक्ट के पास पहुंचाने के लिए एक्सटर्नल फोर्स लगाना पड़ेगा और फोर्स लगा के उसे उस पॉइंट पे पहुंचाना पड़ेगा. तो इन दिस केस force and distance both are present, therefore work is done. Similarly, अगर किसी ऑब्जेक्ट के इलेक्ट्रिक फील्ड से बाहर जहां पे उसका इफेक्ट नहीं है, where no effect can be felt, that means somewhere at a point outside its electric field, that is taken as infinity. So if we take one unit charge, a test charge, one unit charge or a test charge is always plus 1 coulomb. So unit charge is taken from infinity to a particular point inside the field. There has to be some work done. The amount of that work done is the electric potential at that particular point. So simply you can say that electric potential at a point is the amount of work done in bringing a unit charge from infinity to that point. And that electric potential at a specific place has a specific value. That means it indicates how much effort or how much work is needed to transport a positive charge, unit positive charge from infinity to that position. The unit of measurement of electric potential is volt. Electric potential is always known as measured in volts. And again, you will be asked, define 1 volt. You will say that 1 volt is defined as the amount required to move 1 coulomb of charge over a distance of 1 meter. If 1 coulomb of charge is moved in an electric field through a 1 meter and 1 joule of work is done, then it is called 1 volt. Potential difference. Potential, you know, potential at point 1, potential at point 2, they will be different. One will be higher, one will be lower. So if we move 1 unit charge from one point to another within the field from point 2 to point 1, there has to be some work done. So difference in potential means 2 points at having different potentials, and between those 2 points, if 1 unit charge is moved, then the amount of work done will be equal to their potential difference. That means the potential difference between 2 points is given by the formula V is equal to W upon Q. How much work is done, how much charge is moved, this gives the potential difference. The amount of work required to move a unit charge from one point to another is known as potential difference, where V is potential difference, work is W, and Q is charge. The volt represented by the symbol capital V is the unit, the SI unit of measuring potential difference, or simply voltage. Sometimes potential difference is also referred as PD. In your textbooks, P dot D will be written. Don't confuse it because it represents potential difference or simply voltage. Well, that will be the conclusion for the first part. In the next part, we'll take this unit further. Thank you.